Hey guys, let's dive in and get going here. We're going to look at writing or drawing the lines from the given equations today. Random fact, the number of folds in a chef's hat used to signify their level of experience. Like how many ways they knew how to cook an egg. That dude down there must know a lot of ways to cook an egg. Let's dive in. Drawing lines from a given equation. This is exactly what we've been doing, just in reverse. So this should seem pretty straightforward, you guys. Let's look at it. If I was to start with this equation A, and I start with my slope, okay, 2/3, I could count. Where would I start? Where would I start my slope if there is no line here to begin with? Well, I could start at 0. I don't really know where else to start from, so if I start here and then I count up 2 and over 3, I could start with a line right here. But there's really two things going on. Number one, I didn't include my y-intercept. My y-intercept is down here. And also, I took a guess on where to start that line. Why would this be a good place to start the line and not anywhere else on the graph? The point here that I'm making is that you really can't start with your slope. Without starting from a specific place, we're guessing as to where we should put the line, and then we end up in this position, and maybe I can draw something like that. If that green line were an example, and this is just a random line I drew, that's not what I want. I want to be able to move this guy. There we go. Maybe I start him here, but maybe he should have been here with a y-intercept of 1, or maybe he should be here, or maybe he should be here. We don't really know where to place the line, and this is where it should have been with a y-intercept of -2. We don't know where it should go unless we know where to start it, okay? So we can't start with slope. We don't know where to start. We don't know where to go. So we need to start with our y-intercept, okay? We get stuck otherwise. So the first thing we're going to do is see that the y-intercept is -2, and that's where we're going to start from. So we've got our point there, and now we'll do this slope of 2/3 now that we have a place to begin with. And I'll count up to over 3. Now I've got a slope, which gives me a beginning and an ending point to draw my line, and I knew where to start it, which is right there for the y-intercept, and now I just draw my line. Okay, those are supposed to be one line. That was just poorly drawn. There you go. All right, so that's equation A, which I should have made yellow since A was yellow. But I bet you can figure it out. Okay, so there's A. Let's do the same thing on equation B. So we're going to start with our intercept. And again, remember, our y-intercept is also known as B. So we're starting with that because that's going to tell us where the line goes. So it's +3. And remember, that's always the y-intercept. Always, always, always the y-intercept. So I'm going to count up to 3 on the y-axis. There we go. That's where I start. That pins my line to the graph. Now I'm going to count my slope from there. And it's -5. Do you guys remember what it means if it's a whole number? So remember, slope is also known as m, and the slope for this line is -5. Well, we need a rise over run. We need the two pieces of the fraction, but I have a whole number. Do you remember? Hopefully you guys are saying, yeah, Mr. A. Any whole number can be put over 1. So there's my rise over run. It's down 5 over 1. So from my intercept, I'll count down 1, 2, 3, 4, 5 over 1. And now we just connect our lines. I should put a dot there. I kind of missed my dot. Okay, so using my intercept to position my line, that's where it's going to be pinned to the XY axis. And then we count slope from there, and it was a -5, so I'm going downward then over. And there's my second line, line B. All right, so there's a couple examples, just like what you've been doing, but in reverse, and start with your y-intercept. All right, You try. I'll give you a minute. There's your two graphs up here. Go ahead and pause it, graph your two lines, and we'll see if you're right in a minute. Go. All right, we're back. Let's graph A with our yellow. So I'm going to start with my y-intercept plus 1. So I'm going to go on the y-axis to plus 1. And now I'll do the second piece, which is my slope, -4. And hopefully after you guys just saw me, you know that a whole number of -4 just means -4 over 1. So from here, I'm going to go down 1, 2, 3, 4. There's the -4, and then the 1 that's underneath it, the invisible 1. And I've now got 2 points on my line. And there you go. And that would be line A. All right, let's do line B. And again, same idea. Start with your intercept, -2. So -2 means I count down to -2 on the y-axis. It's always y. And then now I work with my slope, 3/4. I've got the position where I start from. Now I will count from that beginning point up 3 over 4. Giving me my second point on my line. And I can draw. That's all she wrote, folks. That's all there is to graphing a line if you've got the equation. Let's write those. That was a 3 upward and then a 4 over. Unfortunately, those two lines are right over the top of each other. Sorry about that, guys. All right, let's move on. Now we're looking at something a little bit new today. These are called special case lines. And hopefully looking at them, ABC, you can tell why they're special case. We haven't had any vertical or horizontal lines yet. All of our lines have been slanted, diagonals somehow. So if we look at, say, equation A, and we tried to count our slope, right? Slope is m. We got to do our rise over run. I'll pick a point where they cross the xy axis. I'll pick another point where we cross the xy axis. And I'm supposed to count up then over or down then over, except there is no up or down. All I've got is straight over. Okay, which means when I try to write the fraction, if I look at this and I say over 1, let me erase a little bit of that so we're not quite as muddled. We'll just do this again real quick. If I'm here and I can't do an up, all I can do is an over of 1. That's going to make it tough to write my slope. I'm going to end up with nothing. I didn't do any up or down, and I just did over. And really, it's not a question mark. If I didn't move up or down at all, then it would be a 0. And so I end up with a slope with 0 over 1, which is actually just going to become 0. And it kills my slope. It makes my equation look different. So I'm going to show you how we write this. Okay. We just look at the fact that this equation A, we're going to ask ourselves 2 questions. Let me back up a sec. If it's a special case, ask yourself or notice, what axis does it cross? Okay. Remember, we're talking about the only axis is X or Y. And so a line A, it crosses the Y-axis right here. So we know it crosses the y-axis. And then the second question we ask ourselves is, where does it cross that axis? And it crosses at +2. Right there, we can see that. So it turns out, if we're going to write the equation for line A, it's the axis it crosses, y, and where it crosses, which is 2. And that's it. It's y equals 2. Now let's look at that for a second and what happens there. If I went with the original form, that we normally use, y equals mx plus b, we can go back up here where we just said the slope ends up being 0 over 1 because there is no up or down, there's only an over. And technically, 0 over anything is just 0. So we could plug in and say y equals 0x. 0 times anything is just 0, however, so that whole thing just disappears. And so all we really end up having left over is the plus b. We end up with y equals, and the 0 times x cancels. So the equation for these is really just y equals b, which is what we had a minute ago. Okay, now, a simple way to remember that is just to come back up to these two rules. They'll always tell you your equation. That's how I remember these special cases. I don't bother thinking about all this or working that out. I just ask those two questions. We'll see on lines B and C, again, how easy that is. So let's go do line B. So I look at line B, I'm right here now, and my first question, what axis does it cross? Crosses the x-axis. Where does it cross? So we've got the x-axis. And where does it cross? It crosses at -1. So the equation for that line is x equals -1. And that's it. You're done. All we do to write the equation of these special cases is what axis is it crossing and where is it crossing it. That makes your equation. X equals -1. Let's try that again on C to see how simple that is. What axis does C cross? Crosses the x-axis. Where does it cross it? At 4. What's the equation of that line? X equals 4. And that's it. Now, to help understand kind of what's behind that a little bit, so this doesn't seem like magic, think about it this way. On line C, every single point on this line has what in common? Every single point on that line has a y value of 4. So no matter what point you pick, or excuse me, I said that backwards, has an x value of 4. No matter what point you pick, the x value of that point is 4, and then the y value is every single number on the y-axis. There's a point at y equals 1, a point at y equals 2, a point at y equals 3, a point at y equals 4. So basically, this line is every single point that exists that has a 4 for the x value, and then anything for the y value. So an easy way to say that equation is just to say x equals 4. Anything where the x value of the point equals 4 is going to be a point on that line. Connect any of those points, you'll have that line. So x equals 4 gives us the equation. We can graph the line just from knowing that. Okay. B, same thing if we want to look at it again. X equals -1. Any point on that line has an x value of -1, and then every single y value that exists is going to be a point on that line as long as you pair it with an x value of -1. So the easy way to talk about it is just to say x equals -1. There's your equation, and there's your line. It makes life easy. Okay? All right, let's look at it the other way. Now I gave you the equation. Let's graph the line, and it's just as simple. A, right here. X equals 4 literally means go to the x-axis. Remember, that's this guy. Up and down's the y-axis. So go to the x-axis and go to the 4 on the x-axis. So 1, 2, 3, 4. 4 on the x-axis is right there. And remember, it crosses the x-axis. This is where kids will get mixed up in the direction they draw the line. We're crossing the x-axis at 4. Oops. You want to cross the x-axis if it says x equals 4. Let's practice it. Second one, y equals -5. So go on the y-axis down to -5. So if we start from center, 1, 2, 3, 4, 5. There's -5 on the y-axis, and we're crossing the y-axis. Let's use a different color, which means we go the opposite. We go perpendicular to the y-axis when we make that line, because our equation crosses the y-axis, and that's equation B. It's at y equals -5, and there we go. Okay, last one. Just wanted to throw this out there for you guys. It's possible. You can absolutely have a line whose special equation is at 0. That doesn't change anything. It just might look a little different, so I wanted to point it out to you. Y equals 0. Do the exact same thing. So we start right here at the center. Start right in the center, and we go to the y, where y-axis is at 0. Well, that's right here. Now, which way do we draw our line? That's the important thing. Remember, you're supposed to cross the y-axis. So if I'm going to cross the y-axis, I've got to go this way to go across the y-axis. And so there's equation C with y equals 0, also known as the x-axis. But my line is crossing the y-axis. Okay? Notice you never go the same direction as that letter. If you've got, for A, you've got x equals 4, you're not going the direction of the x-axis, you are crossing the x-axis, so you go the opposite way. Equation B, if it says y equals -5, you're going to go the other direction than the y-axis. You're going to go left, right. You're going to go across that axis. And then the last one, y equals 0, you're going to go across it the opposite direction of y so that you cross that axis. All right? You guys try it. There's a couple of special case lines for you to graph. Go. All right, let's see if you got them right. A is y equals -3. So I'm going to go on the y-axis to -3. So if I start at 0, 1, 2, there's -3 on the y-axis, and I need to go across it. So I'm going to go that way. There's equation A, y equals -3. I'm going across the y-axis at -3. Second one, x equals 4. Go on the x-axis. 1, 2, 3. There's my 4 right there, and I'm going to cross the x-axis because it says x equals 4. So there's equation B, x equals 4. All right. Here's your guys' homework. We've got a set of lines for you to draw. There's a couple of normal, and there's a couple of special case. And hopefully you guys are starting to see which is which. The normal lines are A and D, the normal equation type, or the normal graphing type equations, because they've got a slope right there, and they've got the intercept, the y-intercept. Okay, they got the two pieces to graph a normal line. So you would graph those just like you always do in that y, equals mx plus b format, okay, that we've been practicing. Lines B and C are your two special cases. Notice, it's missing x. There's no x in there. It's just y equals a number. So that's a special case. It's not in the y equals mx plus b format. And why on earth did I use the same color? Here we go. Okay, it's not in y equals mx plus b format, and then the other one is the same way. That one might be a little easier to notice because it starts with x. It's the only equation type that would start with x. But those are our two special cases because they do not have the same form. They're missing the second variable. They're not set up for anything except a number on the other side of the equation. So graph those 4, and then there's the other thing in exact reverse order, and we'll call these A, B, C, and D. what are the equations for those lines? And again, we can tell our special cases. A is a special case because it's perfectly flat, it's horizontal, so that's a special case line. C is a special case because it's perfectly vertical, it's straight up and down. B and D are the normal lines because they've got a diagonal. So these guys are going to have that y equals mx plus b format. You need the slope and the intercept to graph those two. All right, good luck, guys, and I'll have these answers posted for you tomorrow in the lesson.